we are going to do a really quick review of where we were yesterday. And hopefully it's a nice refresher. And then we can move on to this next thing. Again, Monday, Tuesday, lecture days, not so fun because it's back-to-back, boring. But we'll do what we can to kind of liven it up tomorrow and Thursday. And then I have your quiz written for Friday. So it shouldn't be too bad. But we're charging right along in our schedule here. So everybody did yesterday's lecture questions. We are going to start in your packet on the second page, the page that has the little concept map at the top. Everybody at home, if you got this. It's a different one. It's the second part that I gave you when I said you didn't have to print this off, but this is the second portion. So I gave it to you the last week you were here. Do you need it again? The front of it has a whole bunch of dots on it. I gave it to you the first week you were here. And it was the second half of the unit. Okay. And I said, I want to save you your printer some ink. So I just gave everybody this. Okay. If you need another one, I have them right here. All right. So we're on the second page. So we're going to go ahead and fill this in with all of the terms that we talked about yesterday. Okay. I see you got some of you guys going along here. Yesterday, we talked about pure substances mixtures. Okay. The substance with a fixed ratio of elements. Is that going to be a pure substance or a mixture? Perfect. Pure substance. Very good. Then on the other side, it says substances that are together but not chemically joined. Those are going to be your mixtures. Perfect. Well, I don't know why it's not out. So there, consider that help. Now, out of the pure substances, we had two types. We had atoms and we had compounds, right? Which one is going to be elements and compounds. Which is going to be a single kind of atom? That's going to be an element. Very good. And then elements that are chemically joined together, those make compounds. Very good. Then we have mixtures. This is just another way to define the two mixtures that we were talking about. Uniform composition means it's evenly distributed or it looks the same throughout. And non-uniform means you can see the pieces and parts or whatever, however you want to think about that. But if it's a nice even mixture composition, that's called a homogeneous mixture. Like my copper sulfate yesterday. It's all blue. You know there's water and copper sulfate in here, but you can't see the different pieces and parts. Something that you could see the different pieces and parts of would be a heterogeneous mixture. Heterogeneous mixture. Okay. So with this, I would like for you guys, and I wrote the quiz, and there are some of these microscopic boxes that everybody either loves or hates. They are a few of those on the quiz. So let's get to practicing a few of these. Here's just another graphic organizer here. So again, helium is a pure substance, or nitrogen is a pure substance, and they're considered elements. Compounds are also considered pure substances, and those are when your things are touching or combined in your boxes. And then in mixtures, you have things together. Okay. If it is nice and uniform and even, it is homogeneous. And if you can see the different pieces and parts, it's heterogeneous. Okay. So thinking about that, I would like you to at least do the front of this very quickly. And we can go over it and see how you're doing. I don't know where the other half of it is. Where did you go? Okay, so we'll make sure that you understand what's going on here. I'm going to take some attendance, or at least put your attendance in. So I want you to go through and I want you to tell me, do you think box 1 is representing a pure substance, a heterogeneous mixture, or a homogeneous mixture? And I currently see that there is a distinct lineation between whatever is on top and whatever is on bottom, okay? Because to do the different ones of these are sometimes they're up for negotiation. So let's have you, I'm going to give you about, doesn't take too long, finish the front. The back we can save for the end of the period to give you more practice, but I would like to go through the front and make sure everybody feels swell with that. So I'm going to put some attendance in, finish the front of this worksheet, and if you're at home, also finish the front of this worksheet. I'm going to put the attendance in. And it's okay if you get them wrong. We'll talk about them. This is practice. That's why practice is practice. 10 minutes. Everybody is physics. Beautiful. I'm going to wander around here, see how you're feeling. Got the attendance in. Check. Let me take a real quick look at the lecture question. Beautiful. Awesome. Good job, guys. Good job. All right. Let's chat about it, shall we? See how we're feeling here. And tomorrow we're going to talk about big things like, like a basketball, big things. But for right now, we're going to finish doing our microscopic understanding. Drawing 1, is it a pure substance? No. Now, we have to debate over what kind of mixture it is. If you have 2 different layers, like possibly this might be oil on top, this might be H2O. I know, but they're elements, so that doesn't really work. But you see 2 distinct layers. If you see 2 distinct layers in your mixture, that means that it is a heterogeneous mixture. Okay? If you said homogeneous because it's evenly spread out, I would say on a test or quiz or assessment opportunity, if you can explain yourself, maybe we could do, as long as I'm glad you said a mixture here, but that's going to see 2 distinct layers there. Maybe it's ice on water, something like that. Drawing number 2, is it a pure substance or a mixture? Number 2 is a pure substance. There's only one type of matter. If you reach in, every single thing you pull out is exactly the same. You know that that is a pure substance. Number 3, is that a pure substance or a mixture? That is a, very good, pure substance. And drawing number 4, is that a pure substance? No. I see a couple different things in there. So this is, again, where it gets really sticky, okay? I would have probably taken either of these, depending on your definition. If you say, hey, listen, look, I see black and white dots together and I see gray dots by themselves, I see the differences, you would have picked heterogeneous. If you said, hey, that's really evenly distributed, you would have picked homogeneous. I probably would have stuck with the homogeneous for myself, my explanation. But kind of that's what you're thinking here. You have to at least say it was a mixture. You cannot say it was A. For drawing 5, again, not a pure substance because there's multiple things in there. I probably would have also said it was homogeneous because it was evenly distributed across the whole container. But again, if you would need to support yourself, you could support yourself and say that it was heterogeneous. All right, number 6, non-debatable. Are there elements, compounds, or both in number 1? Just elements, thank you. Number 2, elements, compounds, or both? Elements, thank you. Number 3, elements, compounds, or both? Oh, yeah, compounds. Let me circle the wrong line. Elements, compounds are both in 4. Both. Thank you. And then in 5, we got elements. Good job. So again, it's making you kind of think and understand how matter kind of is, how it would be together. If it was chemically joined, how it would just be in the same container. If it's just physically joined in a mixture, things like that. So we do have the back of this worksheet. We do have the back of this worksheet. But we'll probably put this to the side, and this is something we can do at the end so that we can give some people time to do lecture questions and stuff like that. So take this, flip it over, put it off to the side, and get your notes out wherever you had the notes from yesterday. We're going to do the last note of the week. Wonderful. So right under heterogeneous mixture, we can pick this up. Where are you at? That's my answer key. And beautiful. So you don't even have to write it in 2 different chunks if you want. If you want to say matter notes part 2, go ahead. If you don't, if you just want to do the next one, you can do that as well. Good stuff. All right. So today we're talking about 6 definitions. 4 of them I would bet a lot of money that you've at least heard of before, and 2 of them make you chemistry because they're chemistry specific in the content and in the standards, okay? So 4 of these should be review, should be feeling good. And then 2 of them will be brand new. So if you're like, oh my gosh, after the first 4, trust me, I got something new for you. And we're going to practice these tomorrow, okay? A physical property. if you think of something and I'm like, here's a remote. What's the physical property about it? You'd be like, well, it's gray. Okay, it's a square. It has a certain mass and a certain volume. Physical properties are easy. They can be measured. And again, I would just write the green. They can be measured without changing the chemical composition of a substance. They can be measured without changing the chemical composition of a substance. So we're talking about what it looks like, what it smells like, its mass, its volume, things like that. Good. I don't think you have to write the next part, but just a hint, if you're thinking about it, you don't have to write this down, but it's what you observe with your senses. Okay, so if you can see it or measure it or feel it without changing what the chemical or what your matter is, that is a physical property. We got a couple examples here. Density. I love density because density was a big idea in the last week. So density is going to be, you probably see that on a quiz somewhere. Density is a physical property. It's just the mass divided by the volume. So that is absolutely a physical thing you can measure without changing it. You can jot down any of these or you don't have to. Color, odor, shape, size, boiling point, freezing point, melting point, anything that has to do with physical aspects of the matter. The one that I do want to talk about, though, is solubility. Because over the years, I found out that while everybody has heard the word solubility, I need to formally lecture and formally talk about what solubility actually is. So if you want to put a little asterisk to the side, if I say that salt is soluble, that means it does what in water? It dissolves. And what does dissolve mean? If I put some in here and I stir it up, that means it goes into the water, right? It goes away. It is absorbed into the water. And we can talk more about what that actually means on a chemical level later, but we talk about solubility a lot in this class. And sometimes I just want to make sure that everybody understands what soluble is. A couple other terms, not that you have to write any of these down. We're just kind of talking about it. Solubility is what it is. If you're saying it can dissolve, it's soluble. If it can't dissolve, you call it insoluble. Okay, so, and then when we had done a lab before, I would say, all right, take some sugar, make a saturated solution. The idea of saturated is when there is so much of your soluble material in it, there can't be any more. Okay, so I just want to take a moment and make sure that everybody understands all of these terms, because I think you probably heard them along your scientific career, but now we just made it official. Okay. But the fact that something can dissolve is a physical property of that matter. Perfect. Very good. Very good. Awesome. So physical properties. How it smells, what it looks like, its shape, all that kind of good stuff, all physical stuff. All right. Chemical properties are just the potential to have a chemical change. So the substance's potential, you might just say potential to undergo a chemical change. That is a chemical property. Potential to undergo a chemical change. Awesome. A couple examples. Again, jot down what you want, whatever. If it says it's reactive with water or reactive with sodium hydroxide or reactive with oxygen, and the word reactive is going to give you an indication. pH, if they say it's flammable, anything that tells you that it's going to change chemically is a chemical property. Okay, so those were very, very easy. I'm sure you've heard of them before. They're just in our standards, so we want to make sure everybody's on the same page. Okay. Oh, not only besides chemical and physical properties, we want to talk about chemical and physical changes. So we'll start with physical change. And the biggest thing about a physical change is that you're not changing it on a molecular level. Okay? So it's when a substance does not change its chemical identity. The other thing, if you want to write instead, you can just say no new products are formed, a change in which nothing new is formed. A change in which nothing new is formed. I have a piece of paper here. What is something I can do to this to make it undergo a physical change? Fold it. What else can you do with it? Rip it. What else? You crumple it up. Okay, I could color on it. I could do whatever. But when I do these things, is this not paper anymore? Like this is like now like a monkey and this is dirt. No, it's still paper. So I like to do the ripping one because the indication they put that is that they're usually reversible. However, good luck getting this paper back together. So the usually is usually in here. But if you see that it is not reversible, think about if you got something brand new. And if you didn't get something brand new, then it's just a physical change. Okay. There are two that are always tricky, and I can guarantee you I will put these on the quiz. So let's talk about the two tricky ones, shall we? These are just the ones I've run into over the years that everybody wants to call them chemical changes for some reason, but they're not. So if you want to jot them down, you might know or you might not know that these are physical changes, but these are the tricky guys. The first one are state changes. Sometimes students are like, oh my gosh, that water boiled away. Look at that chemical reaction. And you're like, what? No, okay, no. Because if you think about it, when you have boiling water, it is water, H2O, correct? When you put it into the air, what is its chemical composition? H2O. When you take it and you freeze it into an ice cube, what is it made of? H2O. So unless you've done something to it chemically, it is a physical change, okay? The other one that students often sometimes get confused is the actual process of dissolving, okay? People are like, oh my gosh, that matter went away. That must be a chemical change. And I know that it disappeared, but the number one thing I'm going to come back to is, can you reverse it? Can you get this salt back? Yeah, you can. Boil away the water, salt's back. Nothing changed with the salt. Nothing changed with the water. So therefore, these two are physical changes. Okay? So you can guarantee you're going to put a little star next to those if it was my no task, because I'm probably going to put those on the quiz test opportunity. Good stuff. All right. After physical changes, we have chemical changes. Chemical changes. Awesome. That is when you do make something new. That is when you change the matter at a molecular level. Okay, so put whatever combination of this you want, but the idea is that it changes into or becomes a different substance, and that happens at a molecular level. You are making something brand spanking new in a chemical change. Perfect. You get something new, happens on a molecular level, and these are notoriously irreversible. They're not easy to get back. Now, you can do another chemical change on them, but you can't be like, yo, I didn't mean that. Can you just like undo that? Can you boil that away? That's not the way it works with a chemical change. The last thing about chemical changes, you'll have to be able to, and this might be a chemistry level of this, you would have to be able to give me the pieces of evidence that you see that proves that it is a chemical change. And I think I got about 6 pieces of evidence up here, but let's see if we can't make a visual for this. What is something I could do to this piece of paper to make it undergo a chemical change? We set it on fire. Somebody always says it. So I have an aim and flame here, and we're going to see if we can't find some evidence. Once I start to light this on fire, what are some things that you see that'll let you know that this is, well, that's not fun. I want to keep the orange flame. Well, how do you know that this is becoming a chemical or going through a chemical change? What are some things you're seeing? No worries, just a little fire. It's okay. I think I caught somebody's attention in the hallway. You see what? Okay, it's changing color. Perfect. What else? Is it going away? Do we have, what do you think it feels like up here? Warm. It's warm. It's producing heat. We're removing things. What do you have coming off the top? Maybe eventually once you get that kind of going. You get smoke, you get soot, you get a different odor, all those kinds of things. So before we have our fire drill for the day, I guess, we're going to squelch this. Can I get my paper back? No. I cannot. That's an irreversible idea, and it has several of these pieces of evidence. Now, on all these pieces of evidence, I put the but kind of, making sure I showed you the pitfalls that students sometimes fall into. The first piece of evidence is if a gas is produced. So if I asked you, look at this chemical change and tell me the pieces of evidence, you would say a gas is produced. However, you're not banking on boiling. You're like, but a gas is produced. Okay. That was an but boiling is still physical. Another piece of evidence you will see is if the temperature changes by itself. Once I lit this started giving off a lot of heat energy by itself. You can't say, well, boiling water gets hot. That's because you have it on a hot plate, okay? So it has to change temperature by itself. If it gets hot by itself or it cools down by itself, that's a chemical change. Substance disappearing. Obviously, my paper is gone. Some of it's right here in ash form. But with that substance disappearing, we're not talking dissolving. Dissolving does not count. Beautiful. 3 more, I think. A color change. That's one of the most classic ones that usually you talk about in middle school. You're like, a color change has occurred. Therefore, it is a chemical change. You can see my paper is now blackened. What is left of my paper is now this ashy white color. A new odor. Obviously, even through your mask up here, I can smell the burning paper. And the last one is very chemistry specific. You probably haven't heard of this before because this is something we do in chemistry. It's when a solid is formed, and I'm about to give you another term that I would expect you to know in this class. We're not talking freezing, but what happens a lot in chemistry, and you spend a whole unit on AP Chem talking about what is soluble, what is insoluble, and what's going to form a precipitate. In chemistry, it is called a precipitate, kind of like the rain, but not really. A precipitate is the formation of a solid in a solution. And we're going to do this example for you next week. We do them a couple in the demonstrations on type of reactions. If we were doing labs, one of the labs we do in this unit is you make an actual precipitate. Okay. But a precipitate is a solid formed in a solution. And the one you guys would have done in the lab that was supposed to be tomorrow, but it's got way too much stuff and we have to use the Bunsen burners and all that business, is you take copper sulfate, which is a solution, and you add a clear sodium hydroxide solution, and you get solid copper hydroxide here. So I have a little slow-mo of it. They're going to keep this one on the right as your control, and then here they're going to pour in another clear solution, and when they pour in this clear solution, you will see it is a blue solid that's being made, and that's called a precipitate. You could filter it out and then take it and use it in another reaction. Okay, but so I know it looks kind of liquidy because it's hanging out in there, but that is a solid, and that's called a precipitate. Okay, perfect. So that is one of your chemistry-driven examples of pieces of evidence. So if I asked you what is the evidence, you would need to give me those. Okay. Awesome. Let's do it. We're going to skip that. Last 2 things, and this is brand new. This is only chemistry. It's called an intensive and an extensive property. And you might be like, I swear I've heard that word before. because I talked to you about it when we talked about density. An intensive property does not depend on the system size or the amount of matter involved. Does not depend on the system size or the amount of matter involved. So we said the density of water is what? It's always 1 gram per milliliter. I don't care if you have a cup of water. I don't care if you have a pool of water. I don't care if you fill this room up with water. If you take the mass of it over the volume, it's always going to be 1. So one of the big things here I would write, because I love to put this one on the quiz, density. Awesome. The opposite of an intensive property is an extensive property, and that means it does depend on how much you have. Does depend on how much you have. It does depend on how much you have. A good example of that would be like mass. Okay. If I put 1 penny on the scale and it said 2.5 grams, if I put 10 pennies on the scale, would the number of grams change? Yep. If I put 100 pennies on the scale, would the number change? Yes. So extensive does depend on how much you have, and intensive does not. Okay. I think about intensive is like on the inside. It doesn't matter how big or how small you are. It's an inside property. I don't know if that has any connection to the why they did and they did. But extensive on the outside, if you get bigger or smaller, it does make a difference in the property. Okay. So the activity that we usually do in this period, we're actually going to do tomorrow, so that we can do it with everybody inclusive, and it takes a little bit longer than we could do in one period with our shortened periods nowadays. But so what I want you to do is I want you to get out your lecture questions for today. So fire up your computers. And then after that, I would like for you to finish the back, because I guarantee you, you will see some of these pictures on your quiz on Friday, and the key is in there as well. Okay. So everybody's going to go into week 7. Or it's on the side, which however you want to get to it. Or you can go into week 7, Tuesday. Week 7, Tuesday. Do your lecture questions, the 3 lecture questions. And then finish the back of this worksheet. I think that should be enough. We got 10 minutes. Perfect. Finish the back of this worksheet and then check it with the key. So I'm going to come around with you guys in a second. I'm going to make sure the peeps at home don't have any questions and do some attendance here really fast. Put the jams on quietly. Quiet jams. Quiet jams.